Okay, today I'm just going to show you how to make a classic preferential centripetal Levallois core using a potato, so that you don't have to cut yourself for starters. Preferably wear a glove. I haven't got one here today. Little sharp knife, breadboard, and this will replicate the process of flaking flint more or less exactly. So the way we're going to do this is we're going to turn this kind of egg-shaped nodule, if you like, which is a potato in our case, into a preferential Levallois core, and we're going to start by creating our lower hemisphere on our core. So as we know, Levallois is going to have two hemispheres and it's going to be split roughly in the middle, and we need to create a lower flaking surface, our striking platform surface, and an upper what they call debitage surface, or the domed surface from which our Levallois flake will come. So let's start by taking off our hypothetical flakes by striking, or cutting in this case, slightly angled slices of potato like so. So we're trying to replicate our kind of 70, 80 degree angle. And then we'll do another one here, and another one here. And we'll just keep working our way around the platform like so, striking off these, or cutting off these flakes, if you like. You can see the debitage is already building up around us now, all the way around the outside. So now we've created more or less the beginnings of that tortoise core that we always talk about when we're talking about Levallois. Here we'd have our upper cortical surface at this point unflaked, and you can see our plane of intersection has come right up now, so it's quite high at the top. And here is our more steeply domed lower hemisphere, which is now covered in our flake scars. So this is exactly what we would do on the core, and if you watch the videos on how to make the Levallois core, you'll see me do exactly the same thing. I'll strike flakes all the way around the outside first. Then I'm going to take a series of shallow, broad slices or flakes back in towards the center of our upper surface, our upper hemisphere. So to do that, just carefully now position so you're going to cut quite close to that upper surface. So we're going to imagine as if we are striking a flake that comes up and towards the center of our core. And we just go around and take a series of these, leaving none of the outer rind or cortex behind. And we're going to angle these upwards all the way around so that we end up with a little bit of a doming on the core surface. And this is important that we maintain this doming. So if you look at that now, you'll see this is the length of the core. But if we look side on, you can see that there's that doming, the lateral convexities that we're talking about. And we also want the distal convexity. So here you can see the distal convexity is in position as well. So by creating a bit of a central apex, we've created lateral and distal convexities. And that's really important when we go to take off our Levallois flake shortly. Now, we'll check it at this point to make sure we've got the right sort of outline and everything. So this is probably pretty good. Now we're going to create our chapeau de gendarme at one end. This is going to be the platform end of our core. And to do this, we're just going to create a couple of extra slices to make sure that the top of our core really sticks out. You can probably do it even more. And that's creating the chapeau de gendarme, which is that little kind of policeman's hat of the olden days, or a naval cap, as you might have seen in the 1700s. We'll just check our core one more time. Probably this one's just a little bit too high. Okay, so that's pretty much the perfect Levallois core prior to striking. Now, what we're trying to do is to make our Levallois flake come something like this, so it doesn't run off the edge anywhere and create that overshot. So that's the outline that we're kind of hoping for with our Levallois flake. You can see it there going all the way around the outside. And remembering I'm going to be striking at this end. So how do we now create the Levallois flake? So if this was our core, we'd be turning it upside down and hitting it with a hammerstone right here on the apex of our chateau de gendarme, probably about there, probably about a centimetre or so, or half a centimetre below that point. So we're going to initiate our flake at that point as well. And with one careful cut without cutting yourself, you're going to try and replicate this process of fracture where we slice the flake down like so. So mine wasn't quite as long as some Levallois flakes may have achieved, but you can see how the convexity on the core face has meant that the flake doesn't spill off the sides. It stays within the boundaries of the core. And likewise, our distal convexity prevents that slice, which is more or less just a parallel, just a flat plane that I've cut across there, prevents that from spilling off the bottom of the core and creating an overshot flake at this end. And then here we have our Levallois flake, which you can later cook and eat if you like. So having done this, that's what our Levallois core looks like roughly on a potato. So have a go at doing that, but I want to show you one last thing. And that is that we could then turn this Levallois core into a Levallois point core. And the way this would be done is that some extra flakes would be taken out here. I'm just having to replicate this with a knife, but this would be a series of little blows. And now I've created platforms on the side, and these platforms would be struck to remove this entire edge, what we call the éclat débordant, or the overflowing flake, because it spills off the edges on both sides. So I'll show you now what I mean by that. So I'm going to cut as if I'm taking a flake off all the way to the base. Now you'll see that first flake has truncated part of my Levallois flake scar. Okay, and I've created this long ridge coming down. Now I'm going to do the same thing on the other side. So as if I'm striking a flake, I'm creating this éclat débordant, which comes down the other side now. Now look what I've created on the core now. A nice triangular surface at the top and two planes that intersect to create this long ridge that goes all the way to the base. Now, in the classic Levallois point system, I would just, again, make sure my platform is nice and faceted, and I had my chapeau de gendarme sticking quite pronounced out of the end here, and I would strike on the end here, just like I did with Levallois core, one more time, and I would hope to get a flake that ran something like this down the core face. And you would see, I don't know if you can see that okay, but you would see a Levallois flake would pop off here. And that's your classic type of Levallois flake that was widely employed in the Middle Paleolithic. In the Nubian system, which is a part of North Africa, they would actually take two additional flakes from the distal end, which would further pronounce this ridge and make almost a little lip appear on the very end, a little tip pronounced, but we won't do that today. Okay, so now let's actually strike off this Levallois. So what we would normally do at this point is we'd make sure that there's ample flaking at the back here to make sure our angles are correct, and this would all be heavily faceted around the back here and our chapeau de gendarme sticking right out. And now, once again, using my knife as if it were a hammerstone, I'm going to carefully cut along the surface of the potato towards that ridge, and I would end up creating the Levallois point almost exactly as they appear in the Middle Paleolithic. And here's our resulting, we don't have a bulbar percussion, we've got a bit of a curve, but we've nevertheless got the overarching features represented there. So that would be our Levallois point. So you're welcome to try this at home. See if you can generate a nice Levallois flake followed by a Levallois point. And all the instructions will be in your prac. The other one last thing I'll point out is that our surface of the core now, or our potato, is heavily flaked, and so are the sides. They've got flake scars all the way around, but notice the underside of our core still maintains the cortex, and this is very typical of Levallois flakes and Levallois cores, that they'll often have cortex remaining on the underside because there's no need to flake that area, it remains that way. And you could then in fact prepare this core again and go through the whole process many times. So we end up with our core, our Levallois flake, and our Levallois point rather, and our Levallois flake out of that process.